This is question 5 of Step Paper 2, 2005. Our first task is to prove that 2r equals b plus c minus a, where r is the radius of this circle here, and little a, little b, and small c, which apparently I have left out, are the three edges of the triangle ABC. And the first thing we should note is that this length here, from A to that point there, has to be r, and this length here has to be r. Tangents from an exterior point are equal in length, and that means that this length here is b minus r, so this must be b minus r, because I've just said tangents from an external point are equal in length. And so this is c minus r, and this is c minus r. And so if we look at the edge A, the hypotenuse, the whole of A will equal to b minus r plus c minus r. So A equals b plus c minus 2r. So if I add 2r to both sides and take a off both sides, I have proved the first result required by reference to the fact that tangents from an external point are equal in length. In the second part of the question, we are concerned with big R, which is the ratio of the triangle minus the circle, the small circle inside, to the area of the large circle which circumscribes the right-angled triangle shown in the diagram. If I multiply top and bottom by 2, I get BC minus 2 pi r squared over 2 pi a squared over 4. So of course they go, and that becomes 2. So we have 2bc minus 4 pi r squared all over pi a squared. We know that 2r is b plus c minus a. Q is b plus c upon a, and I have to get rid of everything except q and big R and pi. So if we look at this which we are working on, we need to consider the fact that in the triangle we have been given b squared plus c squared equals a squared. So that b plus c all squared is equal to a squared plus 2bc. And b plus c, if we look here, is qa. So this means that aq squared is equal to a squared plus 2bc, so that 2bc is equal to a squared q squared minus a squared. And this helps us get something on the top which can be later on cancelled with something at the bottom, the a squared. And so if I call this star, star is the same as the following statement. Pi a squared down the bottom a squared q squared minus 1 minus 4 pi r squared. And now if we look at dagger, that implies that r equals b plus c minus a over 2, and I want to get this replaced by something in terms of a, so that r squared is equal to, if we look carefully here, it will be equal to b plus c squared minus 2ab plus c plus a squared, all over 4. And so if you look here, r squared will be b squared plus c squared plus 2bc minus 2a b plus c plus a squared, all over 4. And this b squared plus c squared is a squared plus 2bc, which was a squared q squared minus 1 from before, minus 2a b plus c plus a squared. And that all goes over 4. And if you remember now, q is b plus c over a. So AQ equals b plus c. So if we go along the top here again, we will see that we have a squared plus a squared q squared minus 1 minus 2a, and then we have b plus c, which is aq plus a squared over 4. So let me write that a bit more neatly. We have r squared equals a squared plus a squared q squared minus 1 minus 2a squared q plus a squared, and that all goes over 4. Compress it slightly, and we have 2a squared plus a squared q squared minus 1 minus 2a squared q over 4. Let's get that a bit neater, shall we? And then we can factorize. And so we have r squared equals a squared into 2 plus q squared minus 1 minus 2q all over 4, which is 1 plus q squared minus 2q over 4. And that is a squared over 4 times 1 minus q all squared, and that is r squared. And so if we remind ourselves of our task, we had to eliminate b, c and r from this, from what I'm calling number 1. And a moment ago we obtained what I'm calling statement number 2, and before that we obtained statement number 3. So number 2 says r squared equals a squared times 1 minus q squared all over 4. And statement number 3 says that 2bc is a squared times q squared minus 1. And we're now going to put all that into statement number 1 and see if it gets us any closer to the truth. And so we have 2bc, which is a squared q squared minus 1, minus 4 pi times r squared, which is a squared, 1 minus q all squared over 4, and that goes over pi a squared. So if I multiply this bit out here, I am going to get pi a squared on the bottom, a squared q squared minus 1 there, minus pi a squared 1 minus q squared. And if I can call this statement number 4, number 4 is telling us that this ratio we're looking for is a squared q squared minus 1 minus pi 1 minus q all squared all over pi a squared. And so if I cancel out the a's and I multiply both sides by pi, I get pi big R equals q squared minus 1 minus pi 1 minus q, q squared. Let's get that a bit neater, shall we? 1 minus q all squared. And I have to put this in a particular form, so pi r is equal to q squared minus 1 minus pi times 1 minus 2q plus q squared, which is q squared minus 1 minus pi plus 2 pi q minus pi q squared. So I now have the elements I need. The number of q squared I've got q squared, lots of 1 minus pi. I have got plus 2 pi q, which is one of the other things I need. And I have got minus 1 minus pi, but they have to go into a particular form. So minus 1 minus pi has got to be minus pi plus 1. I've got plus 2 pi q, which I was asked for, and then this one here, I just adjust that to say minus pi minus 1 q squared, and that equals pi times the ratio required, and so I've now done that part of the question. And now to produce the required inequality, I can take this taking that off both sides and putting in the brackets, and regard that as a quadratic in Q, and Q is real, so that what you would call b squared minus 4ac has got to be greater than or equal to 0. So we have 4 pi squared minus 4 times minus pi minus 1 c times minus 1, times pi plus 1 plus pi r, and that has to be greater than or equal to 0. So I've got 4 pi squared minus, there are 3 minus signs there, minus 4 pi minus 1 times pi plus 1 plus pi r, and that must be greater than or equal to 0. And now I can divide both sides by 4 pi squared minus pi minus 1 pi plus 1 plus pi r is greater than or equal to 0. And I am required to prove that r is smaller than or equal to 1 over pi into pi minus 1. So I have pi squared is greater than or equal to pi minus 1 times pi plus 1 plus pi r. If I add that to both sides, I can divide both sides by pi minus 1 because it's greater than 0. And then I've got pi plus 1 plus pi r. And the problem that I have to get here is I've got to make r the subject of that expression. And so if I do a piece of fraction arithmetic here, I've got pi squared over pi minus 1 minus pi plus 1. Now to put that over pi minus 1, I have to multiply by pi minus 1, and that is greater than or equal to pi r. And so on the left-hand side, I have pi squared minus pi squared minus 1 all over pi minus 1, which is greater than or equal to pi r. So pi r is less than or equal to pi squared minus 1 over pi minus 1. So that pi r is less than or equal to 1 over pi minus 1. And if I now divide both sides by pi, I get r is less than or equal to 1 over pi into pi minus 1 as required.